Okay, wrapping up today. Today's workshop, we're going to be doing a panel with three people who I'll actually know personally, are good friends of mine, but also three thought leaders sort of in the space of machine learning and transportation. And I apologize for calling you thought leaders. But the way we're going to do it, I'll be moderating. We're working on the microphone situation. We only have one mic to go around, so I'm going to keep it up here with the panelists. I'm going to give like 3 or 4 questions to each of them just to sort of frame the conversation. And then we'll solicit questions from the audience. Since we don't have a pass mic, I'd ask the panelists to just repeat the question for the benefit of the recording. Sound good? Okay. So in lieu of a formal speaker introduction, the first question of the panel, I'm going to ask each of you to introduce yourselves, tell a little bit about yourself, like try to keep it 60 seconds or less, on a little bit of what you're working on lately. All right?
Very good. Hi, my name is Alex Bayen. I'm the director of the Institute of Transportation Studies at UC Berkeley. I'm also a faculty in the Electrical Engineering and Computer Science department. So 50 seconds left. Basically, my own personal interests are in mobile sensing and the integration of mobile data into mobility models, whether these are from GPS, like we heard this morning, mostly cell tower records, also like one of the talks this morning. And I guess the underlying mathematics that go there are machine learning, so a lot of mirror descent and hedge algorithms and convex optimization. In my second job as an ITS director, our organization has about 200 people working in 7 research centers, some of which put the first autonomous vehicles on the California freeways almost 20 years ago now, some of which work on the certification of these and policy. For example, our researchers were very involved in SB 743 and 375. So we range really from the robotics to the policy and anything in between. So 60 seconds, I'll stop here.
Perfect.
Hi, I'm Chris Pouliot. I'm the VP of Data Science at NextEV. NextEV is an electric car company. We started in late 2014. So there's 2 main principles of the company. One's to build an electric vehicle, and that's important for like helping pollution. And the company, we're going to build a car initially in China. We're going to launch in China, and China has a big pollution problem. So it'll help make China, the blue skies will be coming to China hopefully soon. And then the second part has to do with building a smart connected vehicle. If you think 15 years ago, the mobile phone, all you could do is make and receive calls. But then the smartphone came along, and the smartphone had sensors, mobile internet, computing power, and a good UI. And now it's really transformed our lives. The cars today are pretty dumb, and we want to make them smart. So we really think that the car is going to be the next big computing platform, and that's where machine learning and comes into play.
I'm Jeff Schneider. I'm a professor at Carnegie Mellon in the Robotics Institute and the Machine Learning Department. My research has spanned a bunch of different areas in active learning, anomaly detection, and others. I've applied it especially in the sciences and also in intelligence analysis and the medical industry. Most recently, I'm on leave at Uber ATC, where I'm working on autonomous vehicles, and I'm especially interested in how machine learning can not only make one vehicle work, but can manage the system in the future world where there's lots of them out on the road.
Sure. Great. And by the way, thank you all for doing this. This is a good personal favor to me, and I'm sure all these will benefit. So I had 3 questions, like sort of geared towards each of you. By no means does that mean the other 2 panelists can't chime in, but just sort of to set the stage. So for Jeff, I was sort of thinking about this conference as this really interesting intersection of like industry and academia, right? Lots of great thinkers on both sides of the house. Your personal history straddles this line pretty easily, especially in the field of like transportation and machine learning. Looking forward, over the next like 10 years, do you see industry or academia being the driver, and why?
I think an interesting thing has happened, and I'll just expand that question a little bit. You know, when ATC opened in Pittsburgh, there was a lot of press about the way that happened, with lots of people moving from CMU to ATC. There was a lot of discussion about that being a good or a bad thing. What of course is true, I think we all realize this, it's such an enormous success for CMU and for Pittsburgh. The mission of a university is to create and disseminate knowledge. They create the knowledge through their research and they disseminate it through their education and tech transfer programs. And this is an excellent example of a very successful tech transfer. There isn't any other university that could have created ATC. And so there's a big win there. And so to get back to your question, I think many aspects of autonomous vehicles and their impact on the future of transportation has in some ways turned that corner. It's now becoming something that's really going to be led by commercialization efforts. I think an enormous amount of research will go on in universities, especially looking forward, as I said, looking forward to that world, not so much how do you make one vehicle work, but how does that transportation system look that has lots of autonomous vehicles in it, mixed in with lots of vehicles that are operated by people. I think there will continue to be research in the universities in that area, the policy questions around it. There's an enormous amount of research to be done there, but the specific research of how do you make a car drive itself, I think that one has made the transition, and industry is going to carry the ball from here.
Anything to add, guys?
I mean, yeah, totally to second what Jeff just said. I think that there are areas in which university cannot even compete anymore. I mean, and I think the ones that require massive infrastructure investment, I mean, it's like if you were trying to build the next aircraft, I mean, you would want to do it at Boeing, at Airbus, but not in the university. And I think for the more long-term questions that really, are not going to have an answer tomorrow. I mean, we're going to have autonomous vehicle at a massive scale in the very near future. But things that are more 10, 15 years down the road or more fundamental science-based, then I think it's going to, even though it might be at the forefront of machine learning, will probably still stay at the university. I mean, just think about cryptography 30 or 40 years ago. I mean, it had no obvious application in sight that would take on a massive scale, and today is this completely migrated to industry domain as an illustration, for example, from the past.
I mean, just quickly add, I think through collaboration, through like sponsored research or affiliate programs, there could be a great collaboration between industry and academia. And
sure. Outstanding. Okay, next question. Geared for Alex, again, best effort from the other two panelists. So one of the things that George and I were setting this up sort of consciously talked about when we want to do this workshop was like to make it not just about autonomous vehicles, right? That there's an opportunity space in transportation and machine learning, which is so much larger than that. I think Alex, being the panelist whose experience lately has been furthest from vehicles, not saying it's totally eclipsed, but what do you see as like the most interesting opportunities for machine learning to intersect transportation from your experience, which have nothing to do with autonomy in vehicles?
Well, it's hard to find a topic in transportation that has nothing to do with autonomy in vehicles, but I think the most important impact that machine learning will have on the field of transportation in the next 10, 15 years is basically the modeling of mobility at mega urban scales. Just if you think about what an autonomous fleet does to traffic, and we heard from Jeff, and there's lots of other groups that work on that. But even if you think about the time scales, so autonomous driving could multiply by 2 the distance traveled by people in urban areas very quickly, just because now that you can sleep in your car or have dinner or breakfast in your car, you can live twice as far, and that's really bad for traffic. If done properly, it could reduce congestion, so it could be done really well for traffic. And then if you think about every decision you make, the real estate decision of where to buy your house, the mode of transportation, the time at which you commute and telework versus working from home, all of these time scales that range from decades to seconds will basically be impacted by all these technologies. So I think where machine learning can really help is, as we heard from many talks this morning, you heard from Postdukov's talk, this is joint work we do, on how you can use CDR data from companies like AT&T to forecast things at the scale of a city. Machine learning will have an enormous impact there because basically it's going to enable us to classify data that was previously inaccessible. And I think where we have a responsibility collectively as a community is to create the proper platform for it, because the main difficulty in this field is the fragmentation of the data. You know, all the companies represented here, you all own some portion of data. It's strategic to your business model. It's strategic to your commercial interests. It would also be very helpful for the public agencies to have it, because sooner or later we'll have massive gridlock in many cities. And so I think that efforts we see, like with companies like Sidewalk or whatnot, I think are very welcome to create a joint platform where people can really share data, so we can model this at mega scale. And just, you know, two simple examples that I'd like to mention. One of them is, for example, what if overnight X% of users, 15% of users, starting to use a routing app, whether it's Waze, Google, Apple, Inrix, you name it. This could create massive congestion in suburbs. You see this happening already all around the world. So that needs to be monitored, that needs to be regulated, and that means that needs to be modeled. That's what we do in machine learning. And then another example is, like, how do you model demand to solve the last mile problem? Take a country like Saudi Arabia with Riyadh, with a new metro system of 150 kilometers and 3,000 bus stop feeder system, all built from scratch, just like France after World War II, you know, Marshall Plan style. Suddenly you might have thousands of people in need of the last mile problem solved, and over there it's the last mile in the sun. It's something like 110 degrees, so can't just walk it. How would companies like Lyft, like Uber, like mobility as a service be used for that? And so for that, again, you need a lot of machine learning to model demand from fragmented data, from data that is imperfect, crowdsourced, just like we heard today. So to me, the major breakthrough there is really, you know, how can we as a community help do that modeling to inform the proper agencies and the private sector?
Sure, I'll say, like, and one thing that working on NextEV is how to improve the user experience, like, in the car. So if you think about, like, if coming from an internet background, coming from like Google and Netflix, one thing you do is, like, you instrument everything. You collect a lot of data. How does the driver and the occupants interact with the car? And then once you collect the data, you can come up with algorithms that will improve the user experience. So an example of this is like navigation. So one thing you could do, like, you know, destination prediction, route prediction, and also like route preferences. So one thing that annoys me in my current car, and I have in-car navigation, is like if I'm going from San Francisco down to San Jose, it always routes me on 101. But I really don't like 101, and I really like 280, right? So at 280, very scenic road, you know, smooth road, and also less probability of having an accident in the future. But my navigation system doesn't learn that every time it recommends 101, I take 280, and then it's like, why not? Well, that's a machine learning problem, you know, to learn these preferences, and I think would help improve the user experience. So there's, I think, a lot of machine learning in the car with the user experience, designing things with the user experience as a first and foremost, you know, the top of mind thing would be good.
I think an interesting thing coming up for machine learning is the allocation of transportation resources. Certainly the number and types of transportation modes are increasing all the time. You know, Uber's already done a great job of this for one mode that you don't really plan. You just go when you're ready and you get a car and it's there pretty quickly. We heard some talks already about bikes, making sure that there's a bike for you when you want it. But that's really just the tip of the iceberg, right? Just to come to this conference, how many different modes of transportation did you take? I mean, you took everything from elevators to aircraft, to bikes or cars, trains, subways. Why did I have to buy a plane ticket when I came here? Seriously, why can't I just go to the airport and get on a plane? I think there's a big opportunity for machine learning to do a better job of predicting what resources are needed where and when.
They've already got the surge pricing part down for airlines, so now we just got to work on the scheduling, right? It was funny, Chris, my next question had been, like, you have this unique trajectory within the field of you and I worked on similar problems at Uber and Lyft, and you sort of segued into the vehicle space. Beyond just the personalization part, like, did you feel like your experiences thinking about the networking layer as a whole, like, have uniquely informed, like, the things I build into the vehicle itself?
Let me see if I understand your thing. You know, Or maybe I'll change your question a little bit. I mean, one thing is interesting with one thing with when I was at Lyft and similar to Uber is like a lot of the stuff that the data science team did was like, how do you get someone into a ride, right? So we do things like dispatch and ETA prediction and also dynamic pricing. But once you're in the car, you kind of rely upon the driver to provide this really great user experience. So that's when I saw NextEV was really focused on the user experience in the car. So once you think about autonomous drivers for ride sharing, what is that user experience? It's like, well, I'm just going to be sitting there. I don't know what to do. So that's why I thought focusing on the experience in the car, applying machine learning to make that better is a really interesting problem. And I guess like going back to the network effect of networks, definitely, building machine learning models as you're collecting data and making an aggregate and making some predictions. So everyone's a row of their data set is contributing to the overall algorithm for most algorithms. So yeah, I think definitely you think of information like I think like imagine if cars were networked and if I'm ahead and I see an accident or I slow down, then that information gets relayed to all the other cars in the area would definitely help optimize things, right? But
If you do one thing for all the data scientists in the room with NextEV, like give us a standard schema and data SLA for all the pieces of information coming off the car, I'm sure everyone's going to thank you for like the next 50 years if you could do that for us. Cool. Last question that I'm going to sort of steer, and then we'll start to take hands from the audience. Comes around data sharing and data privacy, right? And I'm not going to ask you this whole like, should we do it? I think that's a given. Is it hard? Absolutely, right? That this is location information, oftentimes probably some of the most personal information you could sort of take from people in an individual point of view. So given that it's important and that it's hard, this is more like a tactical question. Like, do you see there are things that we could do, or if you were like, the way to think about this is like, are there problems that I wish like somebody would just start up and solve for me at the tactical level that we could do right now to get a little bit closer to that sort of like unified data layer, unified transportation data system that you sort of been alluding to? Thoughts?
And tactical, you mean?
As in like right now, not just sort of talking about the field as a whole.
I mean, I think the biggest difficulty is to start a conversation. If you think about what the Smart Cities Challenge did with the 7 finalist cities, Columbus, Ohio finally as a winner, I think the one thing it started in each of these cities is it brought most of the players at the table and discuss about what would be frameworks to share data. I think the biggest difficulty from a private sector perspective is that the incentive bar is pretty high. I mean, getting a company, just taking Google because of the massive amounts of Android data they have, and the value that data provides to planners, to people who are in ops, to people who are in division of maintenance, and all of these divisions of the DOTs and MPOs, I think what it takes is extremely high, and that's why right now that conversation is not happening. So I think it's not calling for a big government action, but certainly federal initiatives like the Smart Cities Challenge have shown that they can shake the ecosystem. And I think with Columbus, we'll see whether that comes to fruition within the next 18 to 24 months. Really, it's a pretty aggressive schedule. So to me, I think it's a very first step towards this. It's very tactical because it's not 10 years down the road. It's like really the conversation needs to be happening now. And I really hope we can see more from these. And I think the more support they get from the private sector, which they totally did this time. I mean, you were there, Lyft was there, many companies were there at the table hosting the Secretary of Transportation when he came to San Francisco. The more like this, I think the faster that will happen.
Any other thoughts, Dan?
I don't know if I have any suggestions other than I wish it would happen, but I'm not that optimistic about sort of top-down methods of making that happen. I think
You mentioned the Top Grand Challenge. Wasn't that a phenomenal top-down approach
that
made it, right?
That certainly spawned a lot of technology. I think that kind of top-down approach to technology, I think, is very good, and I hope that kind of thing continues. Standards, I'm a little less convinced on that one. I hope some big players step up and take a very open source approach to standards, and somehow one emerges that way. That's I'm more optimistic about that direction than the other.
Cool. Okay, so now we're going to take questions from the audience, and the ground rules here will be like, I'll call out people just because of the mic situation, repeat it into the microphone for the benefit of the recording, and then panelists basically flag if any of you would especially like to be the first to answer. Okay, questions. Top of mind for folks. Anybody? Yeah, in the back.
How do we deal with the fact that most government regulation around transportation, specifically in technical knowledge, really lags behind what both industry and academia are doing?
Sure. So I'm going to paraphrase. So how do you sort of deal with the lag between federal regulation and like current state of the art?
I think most companies, are more proactive in terms of government relations. I know at Lyft, Uber, NextEV, they have like a government relations function that they try to work with the legislation of the different bodies and try to help inform and help, push for things that are more modern versus where the current state of it is now.
I really want to thank you for that question, because that really speaks to the service agenda that we have at a public university like Berkeley. A lot of the legislature that is in California was partly written by Berkeley faculty. SB 743 were very instrumental in it. I mean, if you think about all the CO2 certification process, we have an entire research center that works on this. I think the difficulty is the following. So there is a lot of public regulation that just needs to be written by experts that doesn't really rely on specific technology. If you think of all the environmental regulations that have to do with CO2 and whatnot, I mean, in a sense, there the university is a really good place for it. Even in the technology field, if you think about the certification of automated vehicles, so DMV being very involved, and the fact that maybe DMV does not have or did not have at the beginning of the process the right technical expertise in-house, typically what they would do is they would come to a university like Berkeley or to other universities to help them with their certification process. So at the end of the day, I think that it is a very good embodiment of how public agencies have in history, really over the last half century, used the university as their armed technical expertise shop to do that kind of work, just because they realize they don't have it in-house. A government agency like Caltrans, which is the largest DOT in the nation, has been working together with Berkeley since 1947 on that, just because they knew that the public government timescales in terms of hiring the workforce cannot cope with the technological development. This was definitely true after World War II, and this is even more true today. And I do believe that it is an okay model to follow. It's a model that we see kind of happening all around the world, in Asia, in the Middle East, and certainly in Europe. Whether it's an optimal thing, uncertain, but it certainly has enabled the public agency to kind of bridge that gap, which they have a really hard time to do.
Yeah, I think it's a real struggle. No one looks to governments to be the leading edge on things like new technology and regulation. And it's not. It's tempting to call governments incompetent because of that, but it's not fair at all. The people in the government are quite progressive and want to move forward with things, but the reality is that's not where the expertise lies. That's not where the technical expertise is, and so, I think the approach of companies proceeding forward before the regulation exists is going to be the only way it can work. Waiting for government regulations to appear and then trying to innovate to match those regulations will never work. I think companies will proceed, and governments that are good will quickly observe what's there and make sensible regulations that they can apply starting from that point.
I'm not on the panel, but I actually had an opinion on this too, that this actual lag between top-down regulation and the state of the art, you can almost use that as a way to basically sell the more progressive elements of regulatory bodies as a way to basically push the regulatory standard further, basically closer to where industry is at. I think a classic example of this is like how states are starting to like piecemeal approve autonomous vehicle laws or start to like cover policy in this. like some of these states, I think Michigan's a classic example. I'm from Michigan. Like policy regulators are realizing that, you know, if we basically put in autonomous friendly laws now, we're actually going to drive jobs and business to our state. And like that's one dimension that where you could sort of say, okay, if you give us the go-ahead ahead of time, there's actually real benefit to your constituents and stakeholders as well. I think like you can use those techniques. Uber certainly has. I know a lot of other companies are thinking about this along that angle as a way to basically drive regulators basically faster than they'd like to go otherwise. Cool. Yeah, question.
As more and more players enter the self-driving or the autonomous vehicle space, including tech companies, startups, car manufacturers, how do you guys see the competition slash collaboration will play out in the future, like the next 5 years? We will see more consolidation. Are we going to see, you know, a winner takes all, or are we going to see more fragmentation?
Yeah, for the recording. So as the autonomous vehicle space gets more dense, is it going to, do you see, in your opinion, will this be a more collaborative environment or will this be a more fragmented environment?
Yeah, I think there'll certainly be a lot of collaboration involved. There's many levels to autonomous vehicles, everything from the from just the hardware, which you know, a classical car manufacturer would make, to the autonomy systems that are much more high tech and advanced. You know, do I think it's going to be winner take all? I don't think it's going to be winner take all. My model is things like the other transportation areas. You know, there's not only one airline, there's not only one car company, there's not only one aircraft manufacturer. So I don't think it's going to be winner take all, but there will be a lot of consolidation. There's you guys know this. Everyone is trying to do this now, right? And almost all of them will fail. So there will definitely be a lot of consolidation.
I guess I was thinking there might be that maybe there's some kind of consensus on like the sensor stack needed for like autonomous driving. A lot of people like, you know, oh, you need, you know, vision, you need LiDAR, radar, whatever. There's a lot of opinions, and there are a lot of people trying a lot of different, you know, combinations of those. I mean, I was thinking maybe in 5 years from now there'll be more of a consensus that this is the equipment you need in order to, you know, do autonomous driving, you know, correctly.
Agree with all. I just remember the history of the smartphone from developers' hell back in 2005 to how many platforms do we have now? I mean, I think this is a kind of maybe a preview of upcoming events.
Sure. Outstanding. Well, you got time for maybe one more question. Yeah.
Yeah, my question is, how could the advanced technology reduce the gap between applications in industry and those various complex models developed in academia?
Sure. So the question was, how does technology reduce the gap between industry applications and these more academically derived models? Sure. So as more compute hardware comes online, some of these things like neural networks, which you could never really apply in the industry sense, assuming that that comes to fruition, like what do you guys see as the problems or opportunities we could solve in industry? Open mic. Asking the hard questions. I love it.
Let me start with history, but I think Jeff would probably have more up-to-date questions. I mean, if you think about string stability, very classical concept in control theory that came, you know, you could trace it probably to the mid-'80s. I think then the first evidence came with the Hedrick group probably in the '90s. First implementation, '97 on I-15 in San Diego. Who would have thought probably, so 15 years prior to the implementation, that this could be possible? So I guess to me, I would look at the wildest assumptions right now in the literature and things which are as remote as possible or as remote as it can be from implementation as a forecast of what could be done. But I would probably call to Jeff to figure out which one out of these are the most likely to be seeing the light. I think string stability is a really great example of something that was an academic experiment that initially was thought out for aircraft, ended up implemented in I-15 in '97 in San Diego. So maybe there's plenty of those that Jeff can think about now and kind of forecasting the future.
I'm actually going to answer a slightly different question, I think. Mine is just my observations about machine learning technology and how that has progressed, right? That used to be something almost nobody was aware of. And in some version of my talks, I talk about it as now data and learning from it is something that everyone, including your mother, wants to know about and how to do. And what's odd is it's becoming true. Right? You can actually, your mother can now use machine learning and wants to. If you think about, for my own mother, I recently got her a Fitbit for her gift at Christmas, and so that's just one example of something that lots of people are using now to understand themselves and learning from their own data. And I think it's really cool that learning algorithms that used to be confined to academia or special purpose industry applications, they're becoming consumer apps. Actual learning algorithms are becoming consumer apps.
Great. Now my mom is going to nag me about eating my vegetables, getting enough sleep, and not overfitting my models. Okay, that's all the time we have for the panel. I appreciate everybody who attended the workshop. Thank you to the panelists again, and let's give them a round of applause.